As we know, ChatGPT took years of research, and when it entered the market, the need for information searches on Google started to decline. Similarly, in the field of electric vehicles, this seems to be about to happen. Something that even Elon might be worried about. It's Toyota's 1,000-mile solid-state battery. It took years of research, and the Japanese car manufacturer has been pretty persistent with it because they think this battery technology will help them reclaim the market position they lost to Tesla and other brands. A 1,000-mile range kind of seems like a dream. We know you might have doubts too. We did as well. But ultimately, this could be a nightmare for Tesla in the coming years. So, how intense will the race for battery tech become? And why might Elon be a bit concerned about Toyota's new solid-state battery? In fact, it's not just our personal opinion. Many people agree that solid-states are currently the most promising breakthrough technology, or more accurately, the one with the greatest potential to surpass traditional lithium batteries. The advantages of solid states are already significantly stronger than lithium-ion, but that's not the only benefit. In addition to energy density, Toyota's solid-state batteries have numerous advantages in terms of charging speed, safety, and lifespan, fundamental factors that can make a battery a game-changer. Many assert that this type of battery is truly a Tesla 4680 killer. Is that true? Let's start with the concept of solid-state batteries, because we believe that not everyone is familiar with them, especially Toyota's solid-states. Essentially, solid-state battery is a lithium-based battery, kind of like those used in today's electric and hybrid vehicles. But the big difference is solid-states use a fully solid electrolyte, rather than a liquid or gel electrolyte found in conventional lithium-ion batteries. In short, all you need to know is that the electrolyte is a component in the middle of the battery. Think of it like a sandwich with filling in the middle. One has sauce inside and the other has meat as the filling. One's liquid form, the other solid. You should also know a fact: liquid or gel electrolytes offer almost no advantage over a battery cell with a solid electrolyte. If there's any advantage, it's simply that the liquid are commonly used because the industry is currently more familiar with and better developed around them. However, just because we're familiar with it doesn't mean it's better. It's just that the innovations are always an improvement over the old. That's why more manufacturers are choosing solid electrolytes as a replacement, leading to the rise of solid-state batteries. Toyota's become a major manufacturer, daring enough to propose the most ambitious specs for its solid-state batteries, nearly 1,000 miles. The fact is that Toyota actually introduced a solid-state with a range of over 1,000 kilometers or 621 miles back in 2010. Toyota then increased this to 1,200 kilometers with the next generation, and with the final premium version, they're confident their solid-state can enable EVs to get to 1,500 kilometers or 1,000 miles on one charge. That is nearly triple the range of most EVs out there right now. A 1,000-mile range means that this battery could have an incredibly high energy density compared to conventional lithium cells that use liquid electrolytes. Example: Tesla's 4680s have a density of around 272 watt-hours a kilo, and with a 123 kilowatt battery pack, they provide the Cybertruck at least 325 miles of range, so it could get up to 400 miles in a lighter Model Y. Therefore, Toyota's solid-state battery has an energy density of around 600 watt-hours a kilo, meaning it can deliver more than twice the energy, creating a lighter and more compact battery. And that's a breakthrough for electric vehicles, helping increase range and cut vehicle weight, exactly what Elon's been after for several years now. To replace the liquid electrolyte and separator found in traditional lithium batteries, solid electrolytes use solid oxides or sulfides as conductives. Solid electrolytes are denser than liquid or gel electrolytes, allowing solid states to give out more energy for the same weight or volume. Another benefit of Toyota's higher energy density battery is that it'll cut the need to charge your vehicle frequently, saving time and money with lesser charging sessions. With a higher energy density of solid-state batteries, Toyota can up the power and performance of the vehicle, and that's because these types of batteries give higher voltage and current. As a result, acceleration, handling, and speed are enhanced. Just imagine this type of battery combined with Tesla's 48-volt architecture. It is truly exciting. With over 1,000 patents related to solid-state battery tech, Toyota has announced $18 billion worth of investment in development and eventually large-scale production. Clearly, investing in such a promising technology is indisputable, as not only does it double the range compared to conventional batteries, but Toyota's solid-state has also been confirmed to charge as quickly as Cattle's LFP cells, and get this, only 10 minutes. Clearly, we see that all the charging times for EVs are getting shorter with each upgrade. However, compared to the few minutes it takes to refuel a car, a half hour still feels quite a bit longer, and the majority of customers are unconvinced about EVs because they worry about running out of battery in the middle of their trip and trying to find a charging station. Most people aren't trying to wait 30 minutes at a charging station, so faster charging times could help alleviate this concern, and we mean much faster. For Tesla's 4680, it takes about 35 to 40 minutes to charge from 10 to 80%. Solid-state battery tech from QuantumScape, on the other hand, can go to 80% in 15 minutes, which is pretty fast. But with their bold claim, Toyota says their solid-state batteries can go from 0 to full in only 10 minutes, with the potential of reaching speeds of 10C or more, meaning you could take a quick nap in your car for 10 minutes and gain nearly 1,000 miles of range. Pretty unbelievable, right? But the fact is, charging an EV battery pack in 10 minutes has already been tested. CATL, a major partner of Tesla, has also launched 2 super-fast charging batteries, Shenxing and Shenxing Plus, both of which have been tested to fully charge in only 10 minutes. As we know, the solid electrolyte in solid-state batteries has high ion conductivity, which helps accelerate the transport of lithium ions, speeding up the charging process. The battery can hit 80% charge in 10 minutes with less damage to its lifespan compared to lithium-ion batteries, although achieving this requires various methods. Solid-state batteries use metal oxide, metal sulfide, or solid polymer electrolytes, with the softness of sulfur being key to accelerating the charging process. Ions move through sulfur more easily than other electrolytes, with ions going quickly and smoothly, meaning that your charging times are faster. In the case of oxide, they can handle high voltages, meaning that we can push more ions through the electrolyte. Moreover, some studies have shown that solid states can be charged more than 5 times over their lifespan compared to lithium-ion batteries, increasing their longevity. You should know that liquid electrolytes can be negatively affected by high temps. In contrast, solid electrolyte in Toyota performs even better. Since fast charging generates more heat, this feature ensures strong performance during rapid charging sessions. Solid states are highly regarded for their safety due to the use of solid electrolytes instead of liquid ones that are found in traditional lithium batteries. With lithium batteries, the liquid has a very high flammability risk that can easily leak or deform when the battery is damaged or subjected to a strong impact in the case of an accident. In contrast, solid-state batteries eliminate this liquid, reducing the risk of fire or explosion even in the event of a collision. This makes solid-state batteries a much safer option, dispelling the notion that EV batteries are like ticking time bombs. On the other hand, solid-state batteries do not contain flammable components, allowing them to operate safely even at high temperatures. Moreover, while liquid electrolytes can freeze and reduce battery performance at low temps, solid electrolytes remain unaffected, ensuring stable performance. Solid-state batteries are more environmentally friendly than lithium-ion batteries because they use fewer scarce and toxic materials, such as cobalt and nickel. They also have a longer lifespan and lower self-discharge rates, helping to reduce the need for frequent replacements and disposal. Toyota estimates that their solid-state batteries could last for 1 million miles without degradation. However, if we say that solid states are absolutely safe, this would be misleading. Studies show that while solid-state batteries are less likely to experience thermal issues due to overcharging or short circuits, they can still catch on fire if they get compressed or punctured, meaning that if an EV using a solid state is involved in an accident that causes impact to the battery, the risk of fire is still there. It's just not as intense compared to traditional batteries and less harmful. What's the biggest advantage of Toyota solid-state batteries? Good question. Well, nothing is perfect, especially in the field of technology. Every method or product has 2 sides, and Toyota's solid-state battery is no exception. When we ask ourselves why such a promising battery is taking so long, we can easily come up with our own answers. Solid states are not exactly a new concept, and they've been researched for many years. From this, we can easily infer that not only does it require extensive research, but is also not easy to create. According to Toyota's statement, they confirmed that their solid states cost 50% less. Now, don't misunderstand. This doesn't mean that they're going to be 50% cheaper than lithium batteries, but rather they'll be 50% less than Toyota's projected manufacturing costs. However, the buzz surrounding Toyota's announcement mainly revolves around the claim of halving costs. Okay, so traditionally, solid states have been very expensive to make, mainly due to the cost of just the raw materials and purity requirements during manufacturing. For example, the cost of lithium sulfide, a potential material for solid-state batteries, is 5 to 10 times more than that of lithium carbonate. The cost of ceramic electrolytes is also pretty high compared to liquid or gel. Making these batteries also requires a big investment on equipment. Right now, the cost of semi-solid-state batteries is much higher than liquid. Industry research indicates that the cost of semi-solid-state batteries using NCM811 cells is approximately 80% more than liquid batteries. A research institute out of South Korea specializing in new energy and EVs estimates that the cost of solid-state batteries is going to be at least twice as high as lithium-ion batteries. Another challenge is the packaging of solid-state battery cells into battery packs, which also has certain risks. Solid-state batteries are difficult to scale from small prototypes to large packs because they have different thermal expansion coefficients and mechanical properties compared to liquid or gel electrolytes. That can lead to cracking or interface resistance between the electrodes and the electrolyte, and that affects the performance and safety of the battery. Toyota said that they've discovered a new material that can address this by improving the durability and compatibility of solid-state electrolytes. So despite the challenges that the current generation of EV batteries faces, like limited range, long charging times, reduced performance when it's cold, solid-state batteries promise to address all that. Their benefits solidify their position as a pretty hot commodity right now. A lot of battery manufacturers, automakers, and research institutions are investing heavily in solid-state battery tech. However, due to the technical complexity and high costs associated with fully solid-state batteries, most companies are opting for a phased development approach, initially focusing on semi-solid-state batteries. For a long time now, solid-states have been considered the future, promising longer ranges, shorter charging times, and enhanced safety compared to most of the batteries currently used right now. But so far, very few manufacturers have commercially mass-produced solid-state batteries. Currently, the journey from lab to commercial use for Toyota's solid-state batteries is still long and could take anywhere from 3 to 5 years. Some even speculate that this path may lead to a dead end. Despite many news stories about solid-state batteries, no tangible products have been seen quite yet. But it's clear that there are many factors that actively support the process of bringing solid-state batteries to the real world quicker. With the advent of ChatGPT, the efficiency of learning about new materials has gotten better, shortening the development cycle. Thanks to global efforts, solid-state batteries are on track to succeed. Now, it's difficult to predict a specific time when solid-states are going to be widespread and actually replace lithium batteries as the main power source for EVs. Some believe it's going to take at least 10 years for solid-states to get to mass production and market penetration, while others are more optimistic and expect them to be available in the next few years. In any case, solid-states are a promising technology that can revolutionize the EV market, making it more attractive and accessible to consumers and businesses. Toyota takes a different and cautious approach to the electric vehicle market. While it's made its mark with the Prius line and become a pioneer in the hybrid vehicle sector, their entry into the fully electric vehicle market has been a bit slower compared to the competition like Tesla. Instead of rushing, Toyota is focused on making advanced technologies and patiently waiting for their solid-state batteries to reach maturity. Toyota recognizes the importance of collaboration to maintain its position in the technology race. In this effort, Toyota's partnered with Idemitsu, a leading corporation in Japan's petroleum industry, to create something revolutionary. Toyota hopes to combine its portfolio of over 1,000 patents related to battery technology. So, we are really looking forward to the first prototypes of solid-state batteries from Toyota. They're saying 2027, but the testing of the first prototypes might happen sooner before mass production begins. Ultimately, 1,000 miles is a longer driving range than gas-powered vehicles. Cross-country could become easier with this EV, helping to alleviate range anxiety for drivers. The car's battery is not going to be as heavy as current batteries, and reducing weight helps improve the electric vehicle's range since less energy is needed to move the car. A lower weight helps reduce battery consumption, extending the battery's life, and it doesn't stop there. EV battery fires, yes, we know, they can lead to serious injuries, fatalities, and property damage. But check this out. The solid-state materials in Toyota's new battery are expected to be more heat-resistant and stable than the liquid materials found in lithium-ion batteries, which lowers the risk of battery fires due to thermal runaway. Toyota's new EV battery could increase its customer base by making EVs more mainstream and widely accepted. Reliability and safety are two primary concerns for potential EV drivers. Offering a battery that addresses these concerns could help Toyota build consumer trust, enhance loyalty, and improve long-term customer satisfaction. Right now, Elon has shown little interest in solid-state batteries as Tesla continues to prioritize maxing performance, production capacity, and cost efficiency for its 4680 battery line. Clearly, Tesla's focusing on what's most practical and feasible in the short term. Elon is known to be very cost-conscious when it comes to new batteries, and with the high price and unproven feasibility of solid-states, they're not yet a viable choice for electric vehicles. At this point, the concept of solid-state batteries is still a bit ambiguous, with no truly compelling performance or installation cost figures. However, that could change if companies like Toyota or other manufacturers succeed in commercializing solid-state batteries with superior performance. In such a case, it is possible that Elon would take notice and consider a significant collaboration, opening up a new growth opportunity for Tesla. In fact, Tesla's using BYD's Blade battery for the Model Y in Giga Berlin, showing that Elon is not hesitant to adopt competitor technology if it serves the long-term interest of Tesla. So we want to ask you, do you think Tesla should be investing in solid states or continue developing their 4680 batteries? How would you feel if solid-state batteries cost more than traditional batteries but promise superior performance and durability? We believe it is truly worth the price if it lives up to what Toyota's saying about it. And thank you for watching our video. Hey, if you found the content helpful and want to explore more exciting info about Tesla's EVs, hit that like button and share the video. And make sure you're subscribed to Tesla Car World and turn those notifications on so you never miss out on our latest videos. We appreciate your support and hope to see you back here soon. Thanks for watching. Have a great day. Take care and God bless. Bye.